join me in welcoming Dr. Thompson.
Hey, y'all. You doing okay?
We're doing good.
Okay. Well, anybody who knows me, and yes, I did have a Red Bull. Anybody who knows, Anybody who knows me knows that I can't hold still, and so standing up there makes absolutely no sense. And besides, this is participatory, so I'm going to be asking you guys to speak, and Jake is going to handle the microphones up there, and so you guys are also going to be discussing this with me. Sound good? Thank you for being here. It's so fun to see my many hats. There's some EEI, there's some ARI and Institute of Applied Sciences, there's some DSI, there's some TNT. And so actually I need to get you guys all together and introduce you anyway, right? So you guys can all know each other. The role of science education in advancing STEM is what we want to talk about today. And I want to frame it about with the idea of change. And I know my subtitle is a bit on the sardonic side. Without change, nothing changes, a bit obvious, but that doesn't make it any less true, right? So even though this is the topic we're going to talk about, I want to make sure that we all start on the same page. And so I want to talk about, maybe not. This was working earlier. Jake? No, I'd like it to work. It was, I was running through it. So this is the comedy part of the show. Thank you for that laughter. Maybe if I get it started, it'll work. Oh, I have to hit continue because it's being recorded, and no, the recording will not be shared. There we go. Okay. So I want to frame our conversation today, our discussion today on this idea of change, and specifically why we change things if they already work. So according to historians, this particular wheel came about 3500, 3550 BC, one of the first wheeled vehicles, and it was revolutionary. Changed the world as it was known at that time. So why change it? And what I want you to do, there's a technique that's called think, pair, share, where you turn to a shoulder partner, and that shoulder partner could be someone who's sitting behind you, in front of you, to your left or to your right. And I want you to take a minute and I want you to discuss why the wheel changed. If it already works, why change it? Okay? So you have a minute. Are you?
I just was laughing about it. I came up with a Far Side cartoon about the cave-in and the wheel just a day ago and trying to put it.
How funny is that, right?
Well, I don't, weird way things are kind of fitting together. But,
Cool.
and it was about that level of sophistication.
Very cool. Okay, you got about 30 seconds, and then I'm going to bring you back. And 5, 4, 3, 2, 1. Now, who would like to share for their partner and the partnership? So this is the audience participation portion of the show. Thank you. Increase efficiency. Excellent. Yes?
Technology changes brings about the need for more advancement.
Right? So maybe not even about the wheel itself, but other technology change, which then forces a change. Yes?
possibly an issue with mass production, okay, how would he want to distribute it?
Very good. Issue with mass production. How do we get it to the masses? What else? Yes? Safety. For one, I think our kidneys would be safer with something else, but yeah, safety. Very good. I know there's more. Austin? So changing it, what happens if it breaks? Yes? Making it better. Now, can you hear in your mind somebody saying, I wonder if we can improve the wheel, and then somebody else going, wait a minute, it's perfect right the way it is. Don't touch it. That wheel was good for my family. It's going to be good for your family too, right? Don't break something if it's not broken. And you know, there was a group of people that were looking at that wheel going, I wonder if we used a different lubricant. I wonder if we used a different material. I wonder if we thought about changing its shape. I wonder if it was narrower or wider. Yeah? Well, those folks that were doing the I wondering, they probably weren't labeled this back then, but they would be now. Those are mechanical engineers. And the wheel is still a scientific experiment in progress. It never ends. There's always the next innovation or the next I wonder if, and a group of people that are studying that. So here we have a revolutionary piece of technology that changed the world, and yet it too has changed. I want to parallel that thinking with education. Not dissimilar to the wheel. Education is still kind of in a box, right? So it's still kind of rectangular, whereas the wheel is circular. And I still hear those voices, and maybe I'm the only one that hears the voices, and if that's true, don't tell me, okay? Why change it if it works? That's how I learned. If students would just, if they were just stronger, they could move that wheel, right? If they just focused more, if they just... So why change education if it works? Turn to a different shoulder partner. I'm going to give you a minute, and I want you to parallel the idea of the wheel with education and tell me what you think, okay? You have 1 minute.
And yeah, what criteria, how are you defining work? How do you know it's work? Work for everyone.
How are you, sir?
Well, I changed it if it works.
Right? Exactly. Why change it, Chris? Maybe we shouldn't,
Depends.
right?
Depends.
Like on what?
What's that?
Like on what?
Like on,
Yeah.
sometimes some elements of technology, if used incorrectly, changes it.
True. Absolutely. The opposite is also true.
Yep.
Right?
That's true.
Mm-hmm. Very
And
good.
embrace change has to be used from that perspective.
Right.
Not just, oh, look, we got technology.
I agree. Shiny object syndrome? Yeah, not a fan.
There's a lot of that.
There's a lot of that. I agree. Yeah. And shiny object syndrome really isn't based on research,
Yeah, I know.
right?
What's it called? Oh, forgetting my jokes.
It'll come to you. You have about 30 seconds.
Attention, yeah. ADOS. Not ADD or ADHD, but ADOS.
Yeah.
You know what that is, right?
I think I can guess. Go ahead and tell me, though.
It's attention deficit. Oh, shiny.
Very good.
Yes. See too much of it.
Yeah, I agree. All right, I'm bringing you back in 5, 4, 3, 2,
Feel like we're gonna launch.
1. Because we've got a physics prof over here, so he's thinking we're going to launch. All right. So why change education if it works? Why change teaching and learning if it works?
He's got all of it.
Excellent. David has all the answers. It's good to finally know the person that has all the answers. Look, y'all. He's going to kill Chris here in just a moment.
Not till we're done.
Okay, thank you for that. Just sharing out for partners. Yes? Easier access to more information, right? Yes? Right, so needs of society, much like with the wheel, needs of society. What else? Yes? Okay, so technology advancements used for good and not evil. As technology advances, might that influence education? Yes?
We did have, I didn't get your name. Susan was sort of saying that, you know, depending on your audience and their backgrounds, that vary the techniques based on that.
Very good. So making it more student-centered or your audience-centered? Yes?
I think the bottom line is just to make the learning more efficient and more faster. So,
Okay.
Like,
Make the learning more efficient and more faster,
yeah,
right? Much like the wheel.
yeah, exact same. I believe we got same.
Yeah. Okay. Well, believe it or not, yes.
I was going to say, we now know more about how people learn better, the best.
Right. So because of that learning, things change, right? New materials came about. The wheel took advantage of some of those new materials. Yes.
That works is like, it's subjective. It's like, you know, like, and it depends on the professor, the student, and the way of learning, you know, like, and, you know, like what degree they're getting, like how advanced that degree is, you know what I mean? Like,
I do. So she's saying, how do you know if it works? Because there's so many variables. Did I synthesize that? Okay. Everybody learns differently. Different profs teach differently. So it might work for one and it might not work for another. Not too dissimilar to the wheel, right? There are also the haves and the have-nots, right? The people that could afford it had access to the wheel. The people that could not, did not. Okay. So what I want you to think about then is that change in all kinds of revolutionary things, though challenging, can be helpful. Dr. Littler over there talked about, you know, shiny objects. It is not, hey, cool, we've got a new piece of technology, so now let's use it. There's actually, much like with the wheel, mechanical engineers studied. Well, there's actually a group of people that study research specifically within the sciences. So believe it or not, no, I'm not going to say that discipline-based education researchers are comparable to mechanical engineers, but I'm saying in a similar vein, there is a group, a body of researchers that study discipline-based education research. Now, it's defined both by the focus of the research and the researchers who conduct it, and researchers have dual training in science and education research. So when Dr. Padilla, Dean Padilla, was reading off my credentials, you heard in education and in science, also in human learning. So that's what allows me and other DBERs to do research in this area, okay? Now, how many of you have ever heard of, I got my TNTers here, but how many of you have ever heard of discipline-based education research? Okay, got about 6 or 7. So there's a reason for that. Unlike the wheel, it's relatively new. The first actual graduate with a physics education research degree was in the 1970s. Chemistry, the 90s, and it was this century for biology. So this is still an emerging field. And this field has very large, long-range goals. If I could get Sam Nikolai to read the first one for me.
Also identify and measure appropriate learning objectives and instructional approaches that advance students toward those objectives.
Okay. Brian, can I get you to read number 2?
Contribute to the knowledge base in a way that can guide the translation of DBER findings to classroom practice.
All right, Dr. Slaughter, can I get you to read number 3? And there are 2 more, but I've highlighted these because that's actually my area of research. Now, DBER's research varies, much like every research entity. It varies, it can range from fundamental to applied and from theoretical to empirical. Just like with Pasteur's quadrant, it can be pure and basic, it could be use-inspired, it could be pure applied, and of course we all know the tinkering square is the research that we're doing when we don't know what we're doing, right? So I spend a lot of time here, unfortunately, okay? But there is this group of researchers, they conduct research on education in a similar way that mechanical engineers study the wheel, for efficiency, for clarity, for every reason that we talked about for the wheel. We also study education, discipline-based. So these are folks that are not in the education department, but they're in the departments within the sciences. So chemistry education, there's chemistry education researcher at this university, Dr. Molly Atkinson. We don't have a physics education right now. Biology education research, I'm within the biology department. So this is a new trend, at least the last century. This research is financially supportable. And I'm showing evidence here that it is financially supportable by showing you the research that I've received for this subject alone. Just about $15 million since 2006, I've received, along with a lot of other people, from the National Science Foundation, Department of Education, the National Math and Science Institute and Greater Texas Foundation that gave the initial funding for Teach North Texas, shout out, regional funding, and then foundational funding. So what this also means then is that if it's fundable, you tell me, if it's fundable, if people are willing to spend $15 million at the University of North Texas, what does that tell us? Somebody thinks it's important, right? Somebody thinks that there could be change. Somebody thinks that maybe we can make the wheel more efficient, or maybe make it more available, more accessible. Well, what I wanted to do is I wanted to see why. Why are you willing to give me this kind of money? I mean, I'm grateful. Don't get me wrong, right? I'm not going to say no, but why? So if I could get Nancy Terry, could you read this first one for me? So that must be why they're giving money, right? We need more STEM graduates. Okay, Megan, you or your daughter, you want to read number 2? $34%. That's a huge lift. And finally, Ed, you want to read this last one? So there's the why. This is why the funding is coming, okay? The need is evident. So then I thought to myself, yeah, but maybe not at UNT. Maybe we're producing tons of STEMers, right? Maybe we could be a model for other universities on how to change those numbers, and we could be adding to that or decreasing that 34%. So with a postdoc, Dr. Greta Bolin, we studied UNT STEM. And this is a cohort over 10 years, 2000 to 2010, so this is old, okay? But it's the beginning of my story. And what you can see is we've done a heck of a good job in recruitment, okay? Recruitment's expensive, retention is expensive. We have done well with recruitment. What you also might notice, though, is that the trend for recruitment is not evidenced in the graduation rate. Now, there's always going to be a distance. I am not here to say that every person who starts STEM should stay in STEM or would stay in STEM, or I would want them to, right? Everybody needs to find where they are great, and STEM isn't for everybody. But you would hope that at least they would trend in the same direction, not that the gap would get wider. Even if the gap doesn't narrow, at least if they would trend, like the more graduates the more recruitment we have, the more graduates we have. But that's not currently the case. So Dr. Bolin and I wanted to look at some of the variables. And what was interesting about this particular cohort is there was only one variable that correlated with, was statistically significant as an indicator of graduating in STEM, and that was high school rank. So the higher you were ranked in your school, the more likely you were to graduate in STEM. So for instance, the top 10%. We don't necessarily always get the top 10%, but the top 10% of UNT folks. If that makes sense? We're more likely to. Now, the other thing I want you to notice here, and this is what really surprised us. So the associations that we looked at were to get to 100% was student either graduated, they switched major, or they dropped. That got us to our 100%. More STEM students switched majors in years 4 and 5. The top 25% switched in year 4. So a lot of folks I hear from, they go, oh, it just got so hard. That's why they switched. Well, if you're in year 4 and 5, you've gone through a lot of the hard stuff. Year 5, you're looking at graduation, and the top 15% switched in year 5 to a different major. Now, I don't know why, which is why we conducted the next research study. Not only that, what we realized is there's nothing here that we can do as an intervention, right? I can't go and the high school county essentially means school district. I can't move you from one school district to the next. I can't change your rank. When I was teaching at A. Smith High School, the valedictorian in my final year there scored an 800 on the SAT. She was number 1. I can't change your status. I can't change. So what we decided to do is we decided to replicate the study, like all good scientists do, but also look at additional variables. Now, there's a lot going on in this slide, and I'm not expecting or wanting to go through, and I'm not going to punish you by going through all the things on this slide. But I want you to see that we included variables for which we could have an influence, and one of those being GPA. And I want to show you what I love about binary logistic regression, because it's gambling. Anybody who knows me knows I like to gamble, okay? So if you use exponent B, you can get predictive variables. And what this is good for is, if you're going to invest in an intervention, instead of just going after that shiny object, we want to know, if we spend the money, where do we spend it? So we want to have some research that shows us where's the best place to spend the money. If we're going to invest hard-earned money at UNT, so just to show you a little bit about this odds ratio, I want to show you that this here actually showed us that the same trajectory is continuing to happen at UNT in STEM, which it's basically saying that by increasing the number of students enrolled in STEM is not increasing the graduation in STEM. It's decreasing. And so just spending money to recruit is not the answer. We looked at second-year GPA, and look at this. It's 5 times, you're 5 times more likely to graduate in STEM with a higher second-year GPA. So the higher your second-year GPA, the more likely you are to graduate in STEM. Now that's something we can test, right? That's something we could create an intervention for, and we could see, is it true? Okay, this is post hoc data up to this point. So the intervention, there is this book, there is this body of work that's called Scientific Teaching. Joe Handelsman et al. In 2007 came up with this idea that teaching science should have the same rigor as doing science. And so I used to have this as a class, and I could only handle about 10 graduate students at a time. And Dr. Padilla and I were walking across campus and ran into each other, and she said, "Hey, Rudy, can you scale that up?" And I said, "No, I cannot." But then got this amazing graduate student, Claudia, and she said, "What if we put it online? You know, our graduate students are so much smarter than we are, right? What if we put it online? Could we scale it up?" And the answer is yes, and that's what we did. We created GSTEP for Scientific Teaching. These are TAs in biology, currently that's where the study is, that learn active learning, learn formative and summative assessments, both high and low stakes assessments, learn how to teach to a diverse audience, and also they develop and deliver a framework for a teachable unit. We decided to do this research in the 1760 lab because it's early on. And of course, we all know that you can't have a great second-year GPA without a good first-year GPA, right? Those are dependent upon each other. So we gathered the undergraduate student data. This explains it a little bit better. We gathered the undergraduate student data from the same TA, 2 semesters worth prior to them taking GSTEP ST, and then at least 2 semesters after they participated in GSTEP ST. Does that make sense? So if you look at it here, this is TA number 1. The control is the 2 semesters, at least, that the TA taught without GSTEP training. And what you can see here is their retention rate was 13.64%. They were training in how to do GSTEP for scientific teaching. It increased to 28.57%. And after they'd learned and they were doing it the first time on their own, 36.36% for that particular TA. Now, I know that there are my naysayers in the audience and they're going, "But Rudy, that's remote. We all know that everybody just gave grades away and students blah, 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 blah." Okay, well, as you can see, Claudia is continuing this research. We would love to continue this research. And you can see that even as we come back, even above remote, you're seeing an increase. So for TA3, 11% to 42% to 75% retention. So if this works with freshmen and with sophomores, you can see that if we add the TAs together, we retained before GSTEP ST, we retained just under half. We're going to ignore this year right here because we're adding the 2019 in person with the 2021 in person so that all of my remote everything naysayers, right? We can squash that. And you can see that retention went to 69%, okay? And 78.9% for sophomores. So more than half and almost 80% for sophomores. When we look back at the why, this could be a means by which to increase the number of STEM professionals. This could be a means by which to increase STEM degrees, affect low STEM retention rates, and increase the number of STEM graduates. Could be. That's what we love about science, right? There's never a final answer. We're going to continue to study this, but at this point in time, this is what it looks like. More students are retained, which means that they've enrolled in the next biology course in the sequence than they did prior to participating in G-STEP ST. Very strong correlation, moderate to strong correlation for the control, but a very strong correlation with the treatment group. Just letting it sink in a little bit. So what do you think? Not a shiny object. What questions arise when you look at this data? So they're 5 times more likely, and so almost immediately we should see that trend. And again, it's not going to decrease the gap, but it should take the trend line to match.
So it's been 3 years?
3 years. We would love to continue. We're having a couple of struggles with that, but we'll talk about that in just a moment. But we'd love to continue this and see if it continues, if we can continue to see these trends. It can't hurt, right? Unlike the wheel, where you can get hurt if you make a bad decision. By teaching TAs how to teach, there's no harm to the TA or to the students. At least not that I can think of. Yes, Dr. Shaw. Yes.
The reason they were dropping was because of 1760 preparations or something else?
So,
because this is where G-STEP has been implemented in 1760, but maybe some other classes where they are really falling behind and they decided to drop out.
So what we did was we collected the information that led to their GPA. So their GPA increases because their grades are better, which is what leads to retention.
Is that because of the 1760 performance or something else?
I guess I'm confused. Somebody.
I'm saying if they're dropping out of STEM, it may be because of something other than 1760.
Oh, okay. I know what you're saying. All the way back here, this isn't just 1760, right? This is STEM at UNT, period. What we wanted to do is do a test subject, and so we just chose 1760 as our test subject. And in that, this is dropped out of the university. In that case, they could have just dropped the course, okay? So this is what we're doing in 1760 is a smaller sample to see if it can meet the need.
So is there any effort to go beyond that and see whether how this,
Yeah, we would love to. If we can continue in 1760, we can.
What I'm trying to understand is that, when they drop on STEM is more than 1760.
Yes.
Whether this in fact is directly related to G-STEP and here, or something else that's going on in the lab.
Right. Well, we can't know everything that's going on in their life, right? So they're, I mean, just like a mechanical engineer can't know every property that there is in the wheel. But the variables that we're studying, which include ethnicity, first generation status, et cetera, we're also looking at their grades across. Now, these students are taking 1760, and we're only looking at the biology majors. We've actually found that some of the non-majors that take the class have actually chosen to continue with biology. They've actually become majors. So yes, we are looking at all of those variables. There just wasn't enough room or time or maybe even interest to go through all of those. Okay, absolutely. What else? You've given me that look.
I'm just wondering about how much of, I think it's kind of related to what Jody was saying, with how much was 1760 contributing to students wanting to switch out, as opposed to something like Gen Chem or OChem that biology students do struggle with, as well as our own students. And
Right.
so is there something there to do the same thing in chemistry or physics or math or whatever?
Once again, we're on the same
I
page,
was trying to help you like segue into the next.
and I appreciate that. We would love to. So first we had to get all of the steps of the method down. And then we would love to test this in mathematics, physics, and/or chemistry and see, do we see the same effect or do we not? It's a pretty good sample size. I know it's only 3 TAs, but the number of students that they are affecting is a pretty good sample size. So my hypothesis would be that this would be replicable in those subjects. We do look at their grades across all the courses that they're taking during 1760. You know what I mean? So if they're taking a chem course or a math course while they're taking 1760, we are looking at that, but we're not specifically seeing if they're retained in chemistry, math, or physics, only in biology.
And how much do you think the impact of multiple years of experience by the TAs?
Yeah,
how much is
absolutely.
that?
So that was one of the things that we were really interested in. And we know that they get better over time simply by being in it. However, and again, I didn't include this, but we can show it to you later. We also followed the grades of students whose TA did not participate. And their grades, these retention rates did not go up. They stayed about the same. Okay, so that's when Claudia says over here, the mixed method multi-layer, there are so many layers in here, and that's another layer, is looking at those who didn't get any G-step for scientific teaching, no scientific training, and did their students, after they've taught for 6 semesters, did their students improve? It's not statistically significant improvement.
If I can add, one thing which I have observed, students who got G-step without going to the data, their confidence level in instruction has gone way, way up, and communication skills. So that's again a big plus. Exactly.
He said that just from his own experience, aside from the data, the confidence level of the students who participate go up, and their communication skills of the TAs, which is a nice byproduct. Yes?
So I'm wondering about the time commitment of the G-step training and how graduate students are putting that into their full schedule and sort of how that logistically would work.
That's a great question. You're going to connect with Claudia, who's going to wave her hand right here. But it's 1 semester. Currently, it is a non-credit, so there's no cost for it, nor is there a grade for it. It is 1 semester long, and it can be done either before UTA or as UTA. And it's essentially a 1 credit hour course. So if you think along the lines of 1 credit hour. CVAD and the College of Business, they require G-step, not our version, not the ST version, but they require it for all of their TAs before they're allowed to teach. And it is graded, and they get they pay for it, and they get a grade for it, and it goes on their transcript. I gotta tell you, I like that because, first of all, it emphasizes the importance that they are taking on teaching and making sure that their teaching assistants are well trained. Number 2, it's gonna be really good on the CVs of those TAs to say that they have taken a course in how to teach. A lot of I tell my students that it will give you a little bit of an advantage over someone else that you might be competing for, where all of other things are equal, and they see that you voluntarily and/or were required to take a course in teaching. Yes? Mm-hmm. Mm-hmm.
So you have an idea for seeing how the TAs are more employable once this is happening?
Yeah, we would love to continue to follow them. We'll continue, you know, as Claudia says, we'll continue for as long as anyone will let us continue. We think that there's a trove of information that we can continue to find. Of course, we want to add additional TAs, and we want to open it up to different subjects, subject areas, to see if it is, you know, replicable in those areas. It makes sense. It's logical if you know, get taught how to teach, that you might do it a little bit better. But the data is showing that too. Yeah.
Do they continue to have access to the materials that are in GSTEP so that they can like iteratively recruit?
Yes, absolutely. Yeah. Oh, she was asking, do they continue to have access to the materials even after they complete the course? And the answer is yes.
How much control do the TAs in 1760 have over the curriculum?
So pretty much none. It is designed, and that's the other reason why we really like this. They are not developing the content. The content is the same. It's how they deliver it. So we are just talking to them about how you can actively engage your students in the learning rather than it being more lecture-based. Even though these are laboratories, you might be surprised to hear that if you don't know how to engage students, that even the lab can become sort of a mini lecture. Any other questions? Yes. Becky.
Of course, we always, say, train them up while they're young and they'll be great when they're older.
Mm-hmm.
Taking this plan and moving it back to freshman, sophomore, catching them way back when obviously GPA is what matters. That's what you found. Do you think that'll ever come to fruition about this G-step? And then I guess once TAs start learning and then they start teaching, I guess but that takes time. And
It does. That's the hard thing for a lot of folks. So discipline-based education researchers, their research takes a long time. And so unlike some other biology research that may not take as much time, we can't do anything in less than a year. And so it does make it difficult to produce, but sort of like with the wheel, that doesn't mean that change can't occur, and it doesn't necessarily mean that that change is going to be something you and I will notice, but those incremental or evolutionary steps could make a big difference down the road.
so do you feel starting back, once the young ones have been trained up in high school, that we will actually catch better GPAs, which then obviously catches better retention, which
Right.
then...
So current data shows that there's more active learning in K-12 than there is in higher education. So a lot of our students tell us that they feel like they've gone backwards because there's a lot of interactivity. They do a lot of hands-on labs. When I taught, everything was hands-on, inquiry-based. And then they come to college, and a lot of times it's big lecture halls, and they're not quite prepared for that. I think the trend is getting there, and I think discipline-based education research can help inform the higher education community. But right now, there is a disconnect. There's a lot of technology that's used. There's a lot of projects and things like that students do in K-12, and then they kind of come to college and start over with just sit and get.
I won't say wasted time.
For some, as this individual said right here, for some people it works. Like Sam Atkinson, the best lecturer I've ever heard in my entire life. I feel completely engaged. He could talk for hours and I would be completely engaged. Others, not so much. And then not every student that is engaged with Sam's, that is not engaged with Sam's lecture, can learn that way. And so it really is looking at variation, but one instructor doing various techniques within the course, not students having to try it to find another instructor to learn from. Yes?
How are the TAs chosen? Do they volunteer?
Yes.
Do they avoid selection bias, things like that,
Yeah.
or just volunteer bias?
They volunteered and they teach 1760. We just asked, if you teach 1760, would you participate?
Somebody might say that you select for students that were TAs, not students, but TAs that were more motivated to do a better job.
Absolutely. But if you look at their control versus the change after, that doesn't take away from that, right? So they may have been more motivated to learn, but before they learned it, the retention rates were below 50%. Yes, ma'am. No, do it.
On your table that had, you had an N.
I had what?
You had an N of 1.
Oh, yeah. That's where, yeah, sorry. So that's why I was saying, let's ignore this, okay? Because of that, we are still getting the fall 21 data. And so that's why on this, you don't see that added here. That's not a part of this. So we've left that out until we can get the data for 2021 and be back in person. Other questions, concerns? Yes. 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 We do have one individual who didn't TA prior, so that data is not included in here because we don't have a control for them. So they did not TA. The first time they TA'd, they're also taking G-STEP, and we're going to follow their progress too. It's just we don't have a control to compare it to. Questions, concerns, thoughts?
Well,
You're bubbling?
So this is graduate students teaching.
Yes.
How do you get faculty involved in that? Right?
Yeah, that's fun.
Because that seems like that's where you can really have a difference.
I agree. When I first started working with Jim Kennedy and Ken Dixon, I taught in high school, and I said, but I want to start working with younger kids. And so I started the Dallas EEI, and we start working with 5-year-olds. Ken said, you know, Rudy, if it was up to you, you'd probably be in the delivery room. Yes, because they have no bad habits yet, right? Adults, especially faculty that have been doing it for a long time, sometimes there is a willingness to change, but that's a lot of work. And at this university, right, we're supposed to be focused on our research and, you know, bringing in those research dollars and getting the papers out. So I have not tried to emphasize it with faculty out of respect for their time, because they probably wouldn't want to. But it's available. You sure can, and we'd love to follow you. Anybody that, any faculty member that wanted to participate, we would love to have you and follow. Again, none of this was invented by us. This is Jo Handelsman out of Wisconsin, who was a plant biologist until she came up with this idea. We're just implementing it here, so it's good, solid research that was done elsewhere. She's either at Harvard or Princeton, one of those now, that we are using to help UNT, to see if it will help UNT. Yeah?
Are there plans to include any qualitative, I know it's a lot of work.
Yeah. So this is another thing, and I almost included the graphic that you did, Molly. One of the things that Molly, as the chem editor, we're trying to build capacity. So normally, this is very typical. There'll be one biology educator in a biology department. There'll be one chemistry educator. There'll be one physics educator. There may be 15 plant biologists, though they all study different things, but it's still plant-based. There won't ever be 15 biology education researchers in a department. So building capacity, one of the things that we're often called as discipline-based researchers is island scholars. We're off on our own island, we're doing our own thing. Lots of people will pat us on the head, think it's cute what we're doing, but not really take us as serious if we were a bench scientist, let's say. So there are some researchers that do qualitative research. I'm not one of those, which is why I am trying to build capacity. We submitted a grant proposal to the National Science Foundation to begin VRISE, which would be the Virtual Research Institute for Science Education. And it would bring together Texas Tech, UNT, and Texas State. Each of them have one biology education researcher. So with 3 universities, we would have 3, which would be like huge. Chem Ed, there's just a couple. Now at Texas State or Texas Tech, they have a huge math education research department. There's like 15, 18 people in it. That's the first one I've ever seen like that. So we need to get other researchers. This is Dr. Molly Atkinson that I spoke about before. And she does different research than I do, just like plant researchers. There's lots of different kinds of research that's done. If we build this VRISE, we will have some qualitative specialists that can add the qualitative aspect to this research, and we would also replicate this at Texas Tech and Texas State. I'm just not qualified, okay? Anything else? Make sense? Doesn't hurt anybody, right? First, do no harm. TNT is also doing a good job in producing math and science degreed students that also can teach. And so, to go back to your question, Becky, that's also a way that UNT is contributing to that. Our Teach North Texas grads are often seen as second-year teachers. Many of them win Teacher of the Year awards, and it's simply, they're doing the same things that we do in G-STEP. It's interactivity, it's active learning. And so that is happening in the schools more now than before. All right, well, you know what? The only thing between you and a fun beverage, as Pam says, is me. And I would never want to be in the way of that. So I hope that you will join for the reception, and we can talk further. I'd love to, and Claudia would love to talk about it. Another of my graduate students is here, Divya, and she's actually, I'm sorry, Sapuni. I've got Divya on the brain because of the research. Sapuni, and she's actually working with Dr. Atkinson using eye tracking software. And so that's a really cool research study if you guys want to talk to them about that as well. All right, and I just want to thank you for coming on a Monday afternoon. Appreciate you.